Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. Today we do have another Chinese kit, but this Chinese kit is a little bit different than our last one we did because it actually has some sort of labelly QR code thing, so I don't know if that's going to help us. Ooh, and it seems to have a integrated voltmeter. Now that is very interesting because, of course, the Dutch Retro Gamer sent us something very similar to that, and I am having a little look on my shelf of stuff because it was around here somewhere and I can't find it. But yes, he indeed sent me two similar modules, a bit smaller, same sort of thing. So that implies that this is probably a power supply. Oh, got a frog in my throat, unfortunately. Not too many parts. So while I'm having a think about that, I'm going to look in my bag of amazing treats from Jared, the Rebo, the multi-rotor guy sent me. And today's treats are these. And they look scary. Don't know what that is. She's looking fairly satisfied with it as a product. But they do look like meaty, yummy chunks of meat in a chili sauce. But I suspect they're not. They're HBS skewered dried bean curd barbecue. Bean curd barbecue. All the bees, all you need. Right, I'm just going to see, how do I cut this open in such a way I don't make a filthy mess of all of this juice everywhere. I'm just going to chop the top off. Wow, that's thick. That is an incredibly thick plastic. Kind of like the thick plastic that you might have with some sort of industrial sous vide machine and you're going to cook up like a beef brisket or something. Right. Man, that is defeating my blade. Oh, bugger. Should I have done the other end so I could take it out by the stick? And the sticks are all juicy too. It's all covered in juicy oils. Right, I'm going to go for this. This is probably not recommended if you're doing electronics or microelectronics, depending on... Okay, I licked the stick to make sure we could manipulate this properly. Just leave those over there. Right, here we go. It's alright. I'd say they're okay. It's got an undertone of cardboard, so it's a bit like spiced cardboard. I'm just going to bite those off and get on with this. Hang on. Alright, can't talk. What are these? Oh, cool. Alright. Yeah, they're okay. There's a little hint of an aftertaste of spice that's starting to kick in, but I like that. So what I'm going to do is get these standoff things on because they're clearly for this display. Now I have, for this video, adjusted my aperture priority, so hopefully you'll get better zoom focusing when I'm zooming in and out. Less of me having to say, focus you frog. Focus the frog. Right, get that on the way. Wow, there's just so few parts. I love kits with so few parts. Let's go with the horrible parts. Resistors. Signal diodes. They're okay. And regular big boy diodes. So that's the parts we're going to be worrying about. And I've got my multimeter here. Just going to read off these resistors. What a rather weird diagram there. So this is about 230. And then this one will be a 10K ideally. Hooray! It is a 10K. The markings on the board are a bit unusual. They're not the standard kind you tend to see. They've got these interesting roundy groundy shapes, but that's fine. Maybe they were using some new open source CAD package that I'm unfamiliar with, and that's its standard library right now. So far, so good. Tell you what, let's just hit those right away. Let's hit them with the old solder. Hit me with your best shot. Come on and hit me with your best shot. Uh-oh, uh-oh, uh-oh. The old tinning. Didn't want to know. If you ever get that, by the way, you get a PCB and it's hard to solder. If you haven't soldered too many, just go take it away and wash it. Give it a good old scrub. Make sure once you're done with your washing, you've got no detergent left on it if you've used a bit of the old washing up liquid. These are resistors. Resistors activated. This will be 104. Yes, it is a 104. Little cappy cap. Little cappy cap can go in there. In fact, I'm not doing this like the last build where we put everything in and solder it when I go. I'm just going to do it as I go along because I'm feeling brave now. Now that I've had those spicy treats, they're making me just want to just roll with it, be like a rebel and just solder as I go along. No! Already I can see a problem. We seem to be missing one capacitor, don't we? We've only got one capacitor here. Phew, you little hidey. I had a proper little panic on there. I had a proper little panic. I could feel me blood pressure rising. My palms were getting sweaty. I had to mop my brow. It was all happening. But it's okay. Relief. Much relief. Let's continue. And one more. Boom. That's good. That's real good. Now, let's get these little signal diodes in. Might as well just bend all me diodes. There's 4 diodes here, so it's got, I think, a full bridge rectifier. If you ever watch Electro Boom, that's one of his things. He loves the old full bridge rectifier. And I have to say, I do too. I think for the such minor cost in your circuits, if you're designing a circuit that uses a power supply, install a full bridge rectifier, because no matter which way you plug in your AC adapter, it's going to be good. It's going to be correct. So if you're designing a power supply or something, just for your retro computers especially, do it for them, if anything, because sometimes they have all sorts of weird stuff. I remember at school, in music of all things, we had these Casio keyboards. I think they were all Casio, or there was a couple of different kinds of Casio. Some were Casio, some were Yamaha, and it was like the polarity was wrong, and it was always like every lesson finding the right way of putting the bloody plugs in. I mean, it was fortunate they didn't blow up from putting them in the wrong way around, to be honest with you. That would have been a disaster, but it was crap. Full bridge rectifier would have just cost you literally just a couple of little diodes and I missed me foam, and you'd have been done with it. Right, foam attack, go. Man, this board could do with some flux. I got a whole jar of flux actually. Bugger that. It's terrible. It's terrible. It's terrible. So I'm going to use my little thing of flux. Look at that. All the flux all the time. Should probably get a brush or something really. Bing, bing, bing. Oh, that's way too much. Bing, bang, bing. Bing, bang, bong. Bingy, bangy, bingy, bangy, boo. Now, what TV show is that from? Answers on the postcard down below. Bing, bang, bing. Bing, bang, bong. Bingy, bangy, bingy, bangy, boo. Oh yeah, look at that. Look at that. It just makes such a bloody difference in how it flows. It's flowing like a river. Just need something that, what I could do. I've got some syringes, and I always use, actually, generally, if I can, the solder flux that comes in a tube. It's the same kind of thing. Maybe I might try just scooping some of that paste into a syringe, and we'll see if we can make our own solder dispenser. I mean, I'm not sure it's particularly cheap or anything to do it that way. It probably doesn't save you anything in reality, but it's worth a go, isn't it? It's always worth a try. God, that's filthy now. There's so much. I put so much paste. It's like slick with it. What else do we need? We just got a couple of electrolytics, and we got an active component there, which is probably, what is it, an LM317 adjustable regulator. And you got an LED. Oh, let's put the LED in there, always nice. We like the old LEDs on the old back office, don't we? We've got quite the collection of LEDs going on. Let me zoom out a bit. Let's see. You get to see more of the board then. Enjoy the board, my friends. Enjoy the smorgasbord. The smorgasbords. Hang on, is the shaded area negative? Shoot. I can't remember. Bugger. Let's see if we can work this out. I cannot remember if the shaded negative... Yeah, I would say the shaded negative is... area is negative because... My guess is because the ground plane seems to be hooked to it. So, if the ground plane's hooked to it, I mean, that's a pretty good assumption. Oh. Now we've messed it all up. Look at all these big components. Nothing's going to want to sit. This is where you get your tack soldering on. Just tack one leg. Don't worry about it. Just get the old one leg in for now. Stops everything flipping and flopping, flapping out everywhere. Then turn it over. Look, oh, that's pretty perfect as it is. But I might just correct them slightly, ever so slightly. The Lion, the Witch, and the Wardrobe. I was never into that whole Narnia stuff. Sometimes at Christmas they do try to show that. Means nothing to me. It means nothing to me. Right. Now we've tack soldered those in and we still have the legs. But what you can do, you're going to get one pre-soldered leg and one fresh leg. Now if you cut the legs, they look way nicer to solder a already pre-cut leg. It looks just so... You'll just do it. You'll see what I mean. You'll just see what I mean. I'm going to zoom right in, see if we can do it here. You might see the difference. It'll just flow nice. It'll flow in the leg hole, basically. Boom. Look at that. See? It flows in the leg hole. Very groovy. Oh, what a filthy bloody board. Who put so much flux down on this board? It's practically dripping with it. One more down here, hiding away. Is that it? Did I get them all? Hope so. Oh, bridging them. I'm bridging them. So many bridge. I'm just touching these up. I'm trying to give them that fresh cut look. Boom. Right. Give them the London look. What else have we got? We've got this thing with that thing, and we're going to just screw that on. Screw you. So the reason you need a heat sink is because if you have a big difference between your input and your output, it's going to get warm because it has to do something with that energy. Energy. It's using the dark side of the force. Homer! Use the forks. Come on, get in there. That was a tricky one. If you've got a big heatsink like that, you need to pump a lot of heat into the board. So be patient, sit there. Just sit there with your soldering iron. If it's got a temperature setting, whack it up. And let that fill with heat. And then once that heatsink is ready, appropriately warm, that junction, it will flow eventually. Wow, I'm getting loads of bridges with these flux. The flux is making it so liquid. It's got some liquid perfection going on here. Cut those off there. And then we're just going to tighten up that before we forget. That's not going nowhere. Nobody's going nowhere. Never saw nothing. You never saw nothing, boy. Get that in there. That's the input. That is the output. One regulator. So I wonder what the current capacity is of the LM317 because this is quite beefy looking, isn't it? If you have, oh crikey, if you have a retro piece of hardware, and I'm going to say like a Commodore 64 or something like, you could use these. You could use these even internally as a really nice little power supply if you've got room, especially. Might even do a better job than some of the inbuilt linear ones because it's got the nice heatsink ready to go and everything like that. You know, so you could just consider these modules in part of your projects. Let's get a bit more solder. That other leg there. That is looking quite nice, isn't it? It does look professional. This is a nice kit. I don't. Oh, hang on. We've got the screen. So we've got VCC sense and ground. We're going to have to guess. I'm going to make a guess that black is ground, basically. VCC sense and ground. I'm going to go with black being ground. I might be wrong, but it might be right. Let's get that in. Oh my life, look at that. That's some contortion going through. You probably don't even appreciate the contortion that's required to hold those three little dingy dangs. They're technically termed. That's terrible. Come on, flow. Yes. Flow. Yes. Boom. That was not bad. We got it. We flowed it in. Now, what's the right way round? I mean, if you're doing it properly, you could probably shorten the wires. I mean, it's quite a lot of cable here. I'm just going to spin it round on itself. Oh, there's an LED literally underneath it too. That's interesting, isn't it? The LED is actually underneath. Probably an option whether you have the screen at all or you use the LED. But let's fit it and see if we can fit everything else in around it. So now I've got my 3D print. Oh, you bugger! Now I've got my 3D printer set up. One that I'm likely to want to use more. This is the sort of device that, if you're lucky and someone's done a case on Thingiverse, you can just use that. Or if you've got a package like I'm using Autodesk Fusion, trying to learn that 360, that will let you just design cases for these nice enclosures, and then it's actually like a real thing, isn't it? It's like a real device. I'm a real boy with real feelings. Let's get that in there. Crikey, that's tight. How do they expect you to get that in there like that? Ugh. Brute force and ignorance, that's how. Should be a lot nicer to that wire, couldn't I? But that seems okay. Let's just go with it. We want to see it powered up and running. My main concern now is kind of what you could use to give it some load. That'd be a good test. Ooh, these contacts didn't benefit from all the slippery, sloppery soldering flux. Doesn't matter though. We're done now. We are done. Let's take the old soldering iron off. Let's put me knob on. So if you've got a nice panel, you can certainly wire this up with the old panel. And the knob goes from there to there to there to there. So I'm going to go with that for now. That's fine. Okay, input, output. And there's an LED in there we can't see, so good. Let's get our bench power. Oh no, I dropped our chili oil snacks. Don't put your oils on me. Keep your oils away from me. That was always good advice, to be honest with you. If you are walking through a department store and someone is trying to put some salves or lotions on you, never fear in repelling their oily attacks. Is that the inn? No. That's the inn. Oh yeah, cool. And remember, it's got that full bridge rectifier, so you just shove it in any old polarity, should work. as I'm doing here. Now, I don't know what the what is it again? LM317 is good for. It's probably got like 20-30 volt input range on it or something. So I'm going to give it just the 5. So far, so pants. Nothing. Is the LED on even? Yeah, oh, the LED is on. Just not my screen. Maybe the old screen isn't good. You do recall that you did have to wire it up the right way round. Oh no, hello. Hello, tell a lie. Right, so I've got 7.2 volts going in. And I'm playing with my knob. So it's only coming on after a little while. So I'm going to put this right down to off. Increase the input voltage to something like 12 or something realistic. It's like 11 volts. So there's the 10. What is that doing? Okay, interesting. So I've got the, I'm adjusting the input voltage. So the input voltage is, what are we seeing? We've got 15 volts on the input. And we're seeing a 1.2 volt drop. Is that just a 1.2 volts drop across the diodes? Let me check that. We don't know what this does. So 14.35 red measures are there. So you can see the 15 volts coming in basically, and across the first diode you've got 14.3. So you're already losing 0.7. Yeah, and there's the 0.7. You can see 0.7. Then if we measure the output here, we're seeing 12 volts. And if I turn this all the way to off, it still says 12 volts to be fair. No, tell a lie, 1.2. This is weird, isn't it? Let me find a load and we'll do another little test. Very odd. I've just done some testing here. The output runs consistently about 3 volts less than the input at maximum when you have this cranked. And then of course you can wind this down to minimum. But basically the screen on here is showing you pretty much the input voltage minus a bit. Let's work this out. So I'm going to turn the input voltage down to exactly as close as I can on the meter to 11. So there you can see your 1.4 volts out, more or less, and it does seem to track pretty consistently on that. Actually, it's really weird. I personally would have had this on the output. I don't know why it's on the input at all. It's rather strange. I mean, in fact, the sense. If you look at this, what was called the sense wire on it, which is this one, does appear to be connected to the output here. So very odd. And yeah, the black one is ground, the sense is the red, and the VCC is the white. I don't know if the VCC and the sense could be the wrong way round, and it would just give the meter a weird thing, but it's very odd, isn't it? That would kind of maybe explain that when you go down too low, you don't get an output. Maybe, just maybe, I'll try turning those round. Right, it's all soldered in, but before I try that, I'm going to see if I can get this better. I'm just going to loop the old wire around a bit. And I bet you're asking, Andrew, aren't you going to test it first? And the answer will be no, because it makes no difference at this point, because if it doesn't work now, I'm not going to bother unsoldering it. It's going to go into the shelf of shame forever. I strongly feel, though, thinking about the colours that are on that voltmeter, that they basically just made either made the PCB wrong, or really they just couldn't be asked. It was easy to lay the easy to lay the PCB out the way they had it, and they were expecting whoever's installing it to install that the right way around. But that would be pain. If you had these voltmeters with a connector on the end, that would be a right nightmare. You'd have really screwed up big time. You would have screwed the pooch, as they say in some parts of the world. Let's get that voltmeter out of the way. Let's have a little look-see now. So my bench power supply is hovering just on the 11. I'm going to turn it up a bit. Oh, went over 11.01. Okay, ready. Boom. Ooh. So now we're seeing 1.56 volts. Shall we see if that concurs with our readings? Does it indeed concur with our readings? Let's hope it does. 1.6 volts. Close enough, right? We're seeing it. It's kind of close enough. I'm going to turn it up to, let's say, a sweet 2. I don't know. That's 2 there and it's 2.03. I think that's close enough. So that is now tracking the output voltage. We do have our little LED bar here. Let's see what happens. Turn it up. Yeah, boy, yeah! That's good, isn't it? So now I'm maxing it out. It won't go any more maxy, and now our bench power supply is reading 11 volts. So you're consistently 3 volts under. I think I already mentioned that. You're losing 3 volts along the circuit, but damn, that's good. That is good. So I'm rather pleased. Finally a kit that's very useful indeed. So if you want one, by the way, there's the QR code. Maybe I can hold it there for you. Get that going on there. It says the QW019 LM317 kit. In fact, there's a sticker. Look at this. We could do that properly, couldn't we? Look. Boom. That would be worth putting in a box, I reckon, with that knob sticking out. Probably comes with a case suitable for knobbage. But anyway, if you're looking for that, something like that to build as well, I can't recommend that more. That's a fun kit. Go do it and get it cranking your voltages out. As ever, thank you for watching.